Good evening. So let us now start the presentation. I myself Roshika. So I'm here to present the topic applications of predictive calculus in automated theory proving. So let's move on to the topic. So, so before moving into the main topic, let us see that what are the basic things we have to know before knowing that. So in this slide we have introduction to predictive calculus. So, um, so predictive calculus is nothing but the extension of extension of propositional logic, which allows us to work with more complex statements that involves objects and relationships. As you can see here, we have some key components, which is quantifiers, predictors, and variables. Quantifiers are of like two types, so which we have as universal and extra. So actually, the variable, like here we have mentioned variable. So x is the variable, which is human, and this full representation which I have shown here is the predicates. So which we use with the quantifiers as with this, like for universal we can use like h as of like this, which we can use more detailed about. So in this one, in predicate logic we form proportions using components we just discussed, like predicates and stuff. So for example, we have given here the proof, like fundamentals of as I was shown in the before this one. So we can take x as given, and with that predicate symbols we have shown like such symbol. Here the statement is like for all x, if x is a human, then x is not. So here this one, here a same statement we have shown in the formula based statement, which is nothing but like this stuff is known as modus ponens, as you can see in this. Actually, the main this one is, in this case we can prove a statement using rules like modus ponens and universal instances. So this is a fundamental like step you have to know for more detailed paths and things. Now, while coming to the main topic, automated theorem proving. So, automated theorem proving is the like field of AI. So, here we get AI, this one, a branch of AI focused on creating algorithms that can automatically prove or disprove validity of mathematical theorems. So it can prove like true, it is like that logics in the sense same. So in this, it is a part of AI branch, nothing else. So actually, ATP helps in proving statements without human, like logical based reasoning systems. So now in this, as we have known already, this is a topic of our. The PPT system relies on various techniques as like resolution, unification, and induction. So actually resolution in the sense, like it is an informs rules used to derive a contradiction, which help us prove the validity of a formula. Like we can see the example here. So let's see the actually resolution in logic wise. It is like formula has it's like these both will be cancelled out, and we'll just get the result as C. So this is the formula for resolution in logics like that. So while coming to unification is like matches different logical expression, allowing us to combine them for further reasoning. So while introduction is used mainly to prove statements about integers, and it is even essential for mathematical proofs. So to connect to the predicate calculus by using predicates and quantifiers, APT system can handle proofs involving complex relationships like a journey of ATP. Actually, this was introduced in 1950s, so with just a resolution principle. The like first starting step. So they have used algorithm called resolution principles. Actually, while decades pass, even everything like upgrade itself and make it into a better person, right? So yep, same we have your proof techniques in predicate calculus. So your automated theorem proofs like as I told before, resolution, induction, and model checking. So, so resolution is like, as I already told, used to derive contradiction. I mean, it cancels that A part A and contradiction A, like negation A, sorry, contradiction A, negation A, and it gives that B and C part. So that's what is the resolution. And introduction is like to give us a proofs to all the proportions and stuffs. Model checking is used to refer when a model satisfies a given logic formula. It is critical for validating software and hardware systems. So here is the example for that, like using introduction. Okay? So we have proved that. For example, we can prove that a property Pn holds for all like natural numbers n by first proving it for n is equal to 0, then proving that if it holds for n is equal to k, if it holds for n is equal to k plus, like it has to hold n, which is natural. This one from 0 it starts to prove that, but whatever the thing we have, it is like natural numbers are included. So like injection means proving of proportions. So here we have techniques, key techniques. So actually, APT involves these three statements, everything like resolution, unification, and model checking things. So now, like same stuff, even here it is repeated. Same techniques are used here. So each technique plays a important role to enhance an effectiveness of the logic reasoning, allowing system to handle more like complex problems. Even recent advancements in like machine learning and neural networks are influencing APTs. APT's system can now learn from previous proofs and prove their strategy over time. So, like neural networks, nothing but by using neural networks, the APT system can adopt and optimize a proof search process involving their performance or more complex. Like it learns from the mistakes which have done or the data which has already been stored in it, and it stores in the future. It all like collects that and implement it into more effective way. So application of APT in real world. So APT is widely used in software verification where it's critical to prove the correctness of the code and algorithm, ensuring that they don't contain logical errors. So APT is also applied in hardware design to verify that hardware will function as expected. And while coming to mm, mathematical side, which is a tough one for me. So APT is used to prove a theorems which involves automated proving that would otherwise be like consuming like time consuming like stuff for humans who already face a lot of mathematical issues. Just very tough for me also. So yeah, challenges in APT. So while coming to challenges, one of the biggest challenges in APT is like scalability. As problems become more complex, it requires time to find proof increasing proportionally. Like it increases like time proportionally, like n power 2, 3, 4, 5. Like it increases it. So just like scalability is a challenge for APT, and it also struggles with reasoning in the way humans. So from formal verifications like normal registrations or verifications, which we get like identity verified and stuff like that in software, to complex mathematical proofs. We have used AI ATP successfully, and these examples highlight the practical impact advances in equity. So ethical consideration. As APT becomes more integrated into mm, like actually the main goal is like uh, ethical issues related to APT in decision making. So APT system becomes more integrated into decision making, ensuring transparency in reasoning process is crucial. It is also important to ensure accountability and automated reasoning system, especially when they are used in critical areas like law or healthcare. APT systems can initially inherit biases from training data, so ethical oversight is necessary to avoid these biases in automated reasoning. So now I'm coming to the conclusion. So still now we have seen like uh, predictive calculus plays like predictive calculus means a main role in APT. It provides a fundamental foundation of for logic reasoning system that can you solve complex problems across various domains. So while coming to the future of APT, as we continue to integrate machine learning and neural networks into APT, we can expert even more sophisticated systems that will improve the efficiency